Well, thank you very much for that. Welcome everybody. Thanks for turning up. My name is Josh Long. I'm the developer advocate for the Spring team at Pivotal. Uh, uh, Today we're going to talk about Spring Boot and how to build beautiful applications using Spring Boot. For those of you who don't know me, I'm an author on 4 different books, I think, on Spring, 2 different video series. I'm a committer on several of the projects, and I'm generally at your service. So don't hesitate to reach out to me at StarbucksMan on Twitter, and there's my email, josh.long@springsource.com or jlong@gopivotal.com. Okay, so for those of you who've been following the sort of industry for the last year and a half, so many will know that the Spring team moved to a new organization called Pivotal last April, and we joined a larger family of similarly developer-focused technologies, likes of Cloud Foundry, RabbitMQ, Grails, Tomcat, Redis, and of course Spring. Not to mention the Hadoop distribution and a few other pieces. So our mission is to simplify, the development process for developers today, and to help them build modern applications. And we took our mission to heart, because this is a new horizon, a new opportunity. We really wanted to do the best we could, right, by our users. So that path took us a few different places. First stop, of course, was our website. We redesigned it. It's a brand new website. If you go to spring.io, that's the new home of Spring on the web. The application that runs on spring.io is itself a Spring Boot application. It's open source. It's available on GitHub as under Project Sagan. And while I could go on about a lot of the other features on the website, my favorite feature is the guide. The guides on the website are 10 to 15 minute long introductions to various types of application verticals, types of workloads. So if I want to build a REST API, a REST endpoint, I can follow the guide that'll teach me how to do that. If I want to work with a messaging system or a message broker like RabbitMQ, there's a guide for that. If I want to work with a NoSQL or not only SQL, or big data type of system such as Neo4j or MongoDB or Hadoop, there are guides as well. So generally just a good place to get started to learn how to work with the Spring technologies. And of course, most of these guides are also written with Spring Boot. So lots of sort of great things to look at and to read and to sort of follow along to kind of get a feel for what Spring Boot is. Today, of course, we'll be looking at Spring Boot as well. Spring Boot is a focusing of attention. It's a single place where developers can start. It's a place where they can start and consume the rest of what we call Spring platform. So if you look at this architecture diagram, we've got a top level, the IO execution layer that describes our 3 sort of entry points into the platform. Spring XD, of course, is our turnkey big data solution. Grails is our rapid application development centric web framework, and with a very strong Groovy focus. And Spring Boot is our sort of general purpose entry point into the Spring frameworks, what you would think of as the different Spring frameworks. We have those Spring frameworks represented more or less in the IO Foundation box here. Different libraries, different frameworks that you would consume. On the top level, on the IO execution layer, what you're looking at are different technologies that themselves launch processes, right? So the distinction here is one is the foundation layer describes things that are consumed by a running process, and the execution layer describes things that actually launch a process. A process, of course, I mean, more or less corresponds to a thread or pid or something like that. So Spring Boot, again, we want people to be able to consume all these pieces, to consume the very rich APIs that are available in the Spring IO platform, without having to worry too much about what goes where and how to tie it together, without having to understand too much of what's required to wire everything up. The idea, if you can if you can imagine it, is what would it be like if you could have Jürgen Haller, the core guy behind the Spring Framework, the lead Spring Framework committer. What would it be like if you could have him sitting behind you over your shoulder, guiding you on what you're building as you're building application? You'd probably get a lot done a lot quicker, right? If you had that kind of insight. And so the idea was we wanted to codify that, to put it in a place where basically you do actually have somebody like him guiding you, right? You do have the wisdom and experience reflected in your code. Boot is that wisdom. It's our opinion, it's our guidance on how to build types of applications. We express those opinions through sensible defaults that you can rely on when you build your application. So while Boot may sound like it's about bootstrapping, it's not about bootstrapping. It's just about reducing conceptual overhead, right? Conceptual baggage. So with that kind of explanation out of the way, let's turn toward more toward headier topics. What can we do with Boot? How can we use it? What can it be used for? And how can we change the world with it? There are a lot of good answers. I confess I didn't really find a very great one. So what we're going to talk about today is how to build an engine that Dogeifies, if you will, different photos, right? So Doge, for those of you who don't know, is a meme. It's this Japanese dog pictured here that people have made sport of by, adding nonsensical exclamations and texts and so on, and then pairing that with a cute picture of this very, very, very cute dog. So what we want to do is build an engine that automates that process, because why spend 5 minutes photoshopping a Doge image when you can spend an hour writing code to do it for you? So we're going to build this application today, and in so doing, we'll actually look at a lot of the different pieces that Spring Boot brings to the table. The way it'll work is we'll take as inputs a photo depicted on the left, and then we can add to that nonsensical exclamations like "wow," "such grump," etc., along with a Spring Doge seal of approval, and put that all together in a composite, which you can then extract on the other end of the process. If you want to see all this stuff happening, you'll log into the monitor application. So there are two different endpoints, two different views here. One lets you upload files, and the other one lets you, watch what's happening and see it happening, and see all the new updated images as they're happening. So let's actually get started. Let's actually do that. There are a couple ways to get started with Spring Boot. The first one is, of course, just start.spring.io. Start.spring.io is just that. It's a web service. You can go there and just fill out the form. You see fields here, that reflect the usual suspects: the Maven project group ID, the artifact ID, the name of the project, a description, the packages, etc. And then you have checkboxes, and these checkboxes, again, these correspond to types of application workloads. They don't correspond to specific technologies, or at least we don't want them to, right? We want people to think about it in terms of broader strokes than a specific framework or a technology. So suppose I want to build a web application. Check the web tier checkbox. Suppose I want to work with ORM for SQL, and a natural fit there is JPA. So I'll just choose JPA. Hit generate, and I'm given a zip file, which I can unzip and start working with. This works with anything, right? It's just a standard Maven build, or a standard Gradle build, if you like. You can open it up in any IDE of your choosing. Of course, there's no magic here. Just open it up. Standard Maven. But we're going to use STS. STS is our open source Eclipse distribution. It represents a superset of the latest and greatest Java EE distribution. So at all times, you'll have everything in the latest and greatest stable cut, plus a lot of extra great stuff. And when I say extra stuff, I mean, for example, that STS had preliminary Java 8 support in Eclipse a full 6 months before regular Eclipse had it, for example. Or STS had preliminary Gradle support a long time before it was generally available in Eclipse. So there's a lot of good stuff here, typical stuff that people are clamoring for, but it hasn't been, it hasn't made it into the main projects yet. Now, in STS, there are some really handy tools. For example, if you go to File, New, Spring Starter Project, you're given a wizard. It looks familiar, I would imagine. This is the same wizard that, basically it's the same wizard that we just looked at before. You choose different types of, let's see, demo one, there we are. You choose the type of vertical that you want to work with, for example, JPA and web. Choose specify the group and the artifact, etc. Hit next, and you can see the actual URL. The URL in this text box is the same URL that you paste into a browser to get that generated zip file containing a build and some preliminary source code. It's the same URL. So this UI dialog is just a front end for that web service. So again, use either one. It doesn't really matter. I've already got a simple sort of example there. So, actually, I don't here. I'll go ahead and do that. So let's see. So I'm going to go ahead and choose demo one, choose web. Suppose I want to work with JPA. I'll go ahead and hit next, hit finish. And we'll see here, I've got a fairly sort of uninteresting project here, right? So I've got an empty test class, again, nothing particularly special. I've got a default empty property file, and I have an application class. And this application class is just an entry point. It just has public static void main, and public static void main has one line. It has a call to the Spring application.run method. This is a Spring Boot specific class. It in turn returns a reference to the Spring application context. So you just go here and you can assign that, right? Again, you shouldn't usually need to deal with the application context, but it's nice to know that there's a very convenient way to get it if you like. So what we're doing is we're saying to Spring, okay, create an application context, take as your initial input the application class itself. Spring Boot will discover that there are regular Spring annotations like the @configuration annotation, which signals that this class could be a bean definition configuration class. There's the @component_scan annotation, which tells Spring to find all beans annotated with so-called stereotype annotations in the package that we're in right now, or a deeper one, and register them as beans. So this is just typical component scanning. And then finally, we have the Spring Boot @enable auto configuration annotation. This annotation tells Spring Boot that we would like it to, on our behalf, based on whatever it can infer from looking at the class path and from the Spring Bean context and from the environment and anything else that it has a visibility into, to do whatever it can to remove work from my path, to give me sensible defaults. And this is the magic, right? This is where we really, really win, is because Spring is going to do whatever it can to give us sensible defaults. It'll do that through just regular old Java configuration. We'll look at that a little bit later. For now, with that out of the way, let's actually turn to a sort of more sophisticated version of the same code base. I've already gutted the bulk of the code, and we're going to go ahead and rebuild it up. I won't bore you with all the details. One thing you should know, though, is when we look at this build file for the simple starter that we looked at earlier, even the build file is sort of an opinionated way of solving a certain kind of problem, right? Which is that of dependency management. So first, our build file, it points to a parent build. In this case, one provided by Spring Boot. That parent POM has managed the versions of dependencies across all the major Spring projects. And it has also managed the versions of dependencies that those Spring projects are likely to need or use, right? So again, if I need a Hibernate, or if I need a logging API, or any of these kinds of things, again, there's probably a version that's already specified in the parent POM. Moving down a little bit, you can see there are three different dependencies here. One's a test dependency, which is strictly speaking for the test code, and that's just there by default. And then otherwise, you have two different dependencies. These two different dependencies correspond roughly to the checkboxes that we selected earlier in the wizard. We selected web support, and so we got a org spring framework.boot spring boot starter web dependency. And we also selected that we wanted JPA support. So we got org spring framework boot spring boot starter data JPA. These dependencies are already a change in the status quo from what you might be familiar with in the Spring world. If you think about the Spring ORM module, that module supports, for example, JDO and JPA 1 and 2 and Hibernate 3 and 4 and JDBC, etc. So there's a lot of different pieces there, and if that build, if that that dependency had all of the types that it depended on, if it had those types marked as anything but optional, they would all be transitively imported. So it'd be very quickly just sort of a really, really painful, ugly mess. You wouldn't want Hibernate 3 and 4 and JDO and JPA support, and all these different libraries on your laptop at the same time. It'd be mayhem, craziness. It'd be dogs and cats living together. It's my favorite line from Ghostbusters. So, it's to be avoided, right? That's what we're doing here is very different. What we're saying, you asked for a dependency that'll support JPA workloads. This is a well-known, well-tested, well-integrated stack. This is not the kitchen sink. This is just what you need to get started. And it's reasonable. It's the sort of sensible stuff, the stuff that you're not going to want to have to think about later, right? So again, this is a fully fleshed out stack, but it is a focused stack. We're not trying to support every permutation of data access here. We're trying to support a well-known stack. In this case, you're going to get Hibernate, you're going to get JPA, you're going to get, the requisite Spring modules and so on. Again, the same thing up here for the web module. You get all these pieces with that one tiny little opinionated dependency. You'll notice that we don't have any versions here either, right? These versions, again, they're managed by the parent POM, and the implication is that if, in say a couple years time, for example, Spring Boot, who knows, 2 or 3 or whatever, if that version comes along, we change the version here, it's fair to assume that the versions that are managed by the parent POM will also get upgraded, right? You'll also see those up, and that's a big win, because you're no longer in charge of certifying that these pieces work together in a seamless way. It should just work, right? So it should be a lot easier to move to a new version. Again, this is not even, we're not even here to talk about Maven dependencies, but it's just one of those really nice touches that exemplify why Spring Boot makes it very easy to move quicker, Okay, moving to code now. Now that we've got an understanding for what a basic project looks like, we're going to return to this Spring Doge project, and we're going to build that application that we described earlier, something to Dogeify images. I suppose the natural first step in this case is to worry about data access, right? We're going to use MongoDB because why not? MongoDB is a perfectly fine instrument for storing data. I've got a little cheat sheet here. I've got some classes and code already written, so I don't have to toil typing it all up in time. So we're gonna have a simple domain model for user, and then the user can manage end-to-end photos. We're going to store the photos on MongoDB's GridFS file system. This is a natural fit for those who are trying to build cloud or PaaS platform as a service aware type applications, where often there is no durable hard disk. So we're going to build first the user entity. Okay. And paste that in there. And you can see I've got an annotation. The annotation comes from Spring Data Mongo. It's an annotation that it's a lightweight ORM mapping, if you will. So we're saying to Spring Data Mongo that we want this object to represent a beacon structure, a BSON, which is the binary JSON format that Mongo uses. We want this to represent the data in one of those collections, in a user's collection, if you will. And we want this field to be used as the index, as a key. Obviously, the annotation means different things in different contexts. If you're using Spring Data Gemfire, Spring Data, Redis, or Spring Data Neo4j, then you'll have a different set where appropriate. So okay, that's a simple user. And as I mentioned, each user can manage 1 to n photos. So we'll have a type to describe Doge photos. Okay. Add a class there. Paste. Voila. So we have now a Doge photo which has an index, an ID, and it has a pointer to the user that contains it, right? So this is the collection that contains the photo data. And then in the photo data, all we do is we pull the name of the file for the photo that can be looked up on the GridFS file system level. Well, with those, we've got two entities now. We've got two different details or objects that can be mapped to the records in the database. We now need some actual way to do that mapping, to actually execute the queries and the reads and the updates and the deletes and so on. And in most systems, that corresponds to the repository layer, right? So a repository is a natural vehicle for CRUD style code. So we're going to create a Doge photo repository, a repository for dealing with Doge photos. And we're going to do that by building on top of Spring Data repository. Spring Data's repository support. Repositories map more or less to the idea of active record objects in Ruby and Rails, right? They're convenient ways to, based on convention, create, finders, create read, update, delete style methods. Here we're defining an interface, and the interface extends the Spring Data Mongo repository interface. We've typed it to Doge photo and string, where Doge photo is the type of entity that we want to manipulate, and string is the type of the index for that entity. So what we're saying is we want to create a repository that can manipulate Doge photo entities, and those Doge photo entities have an ID field that's of type string. If you kind of click around, you can see the Mongo repository interface then defines different methods for saving and querying different types of data in certain numbers. This interface then extends the paging and sorting repository, and then in that interface, you'll find methods for finding all of a given type and finding all of a given page, etc. And of course, in that you'll find the CRUD repository, which you'll find methods for saving an entity, for saving many of an entity, for finding one by its ID, etc. Right? So very common cases are already well supported. And note that we haven't written any code. All we've done thus far is written an interface that extends another interface, but no implementation. We're going to do the same thing for our user data. So I'm going to create a user repository, like so. Okay, paste that in, and we're off. There you go. We've got two different repositories that can be used to manipulate our different entities, making short work of all the create, read, update, and delete style logic that most people spend a lot of time writing. This is boilerplate stuff. This is stuff that you shouldn't have to write. So don't. With Spring Data, it's really not hard to avoid writing all that stuff. With that out of the way, we can now actually just go ahead and use our repositories to install some sample data, some test data. So I've got here a simple bean definition for an initializing bean. We're using Java 8 in this example, and in Java 8 you have Lambda expressions. Lambda expressions are assignable to instances of interfaces that are so-called functional interfaces. That is, they are said to have one abstract method. In this case, initializing bean is a functional interface by default, right? So it's an interface with one unimplemented method. Recall that in Java 8, you have default methods in interfaces. So I use the distinction one abstract method for a reason. You could have an interface with 10 methods, but 9 of them could be default, and so the rule still applies. You can still assign a lambda expression to that interface, as we are here. So this is a lambda expression. The body inside the curly brackets is eventually pushed inside of a class that implements this initializing bean interface, and then that is returned as the bean here. As with all Java configuration, this is a Java configuration bean definition provider, and the class of the bean is going to be the initializing bean interface. The dependencies that this bean needs to do its work are enumerated as arguments for the factory method itself. So here we're saying, Spring, I need a pointer to the usable repository object. I don't care where you get it, just find it for me by type. And of course, it's going to find the implementation of the interface that we've just defined for user. With that in place, we can save data, right? So I've got 3 different records I'm going to save here. I'm going to go ahead and add the amazing Dr. Sire. Like so. And Phil Webb's up here, of course. These are the 2 co-leads for Spring Boot. Thank you, gentlemen. And then down here, I'm going to query all the records in the database and enumerate them. I'm going to just have, I'm going to use the collection, the new methods in the collection interface to iterate over every record and then call, based on this method reference, the printline method for every object. Right, so this is going to pass X for each X in the return collection, and then pass X to the system error printline method. And okay, so with that out of the way, let's go ahead and see if we've made progress. Go ahead and start the application. Off to a good start. I don't know if you saw that enterprise grade ASCII art up there, but that's important. There you are. That is some good stuff. Maybe it's not actually that important, but I really like it. And then down here, as promised, you'll see here that we have system.error, printline. So what we're doing is we're sending to system error every record in the database, and in this case, the 3 records here, and then printing it out. And you can already tell we've got, if you actually looked at a Spring Boot application on a regular POSIX terminal, modern one probably, it supports colors. There's some very, very, very sensible defaults for everything, including logging. So by default, logging is not very aggressive, and it's well colored and well styled. So it's very easy to glance at from afar and kind of parse the information by the shapes and colors of the text. It doesn't overwhelm you with just noise, Okay, so we're off to the races. We've made good progress here. We've got a working data tier up and running. We've got 3 different records in the database. Now what? We need to build a service, something that'll consume the repositories, something that'll expose coarse-grained business operations to the client. So we'll create this class here. Doors service. And of course, I'm going to just go ahead and grab the bits for that here. And what you have is a regular Spring Bean annotated add service. So it'll be picked up in the add component scan suite that we looked at earlier. And then it in turn defines 3 different Bean dependencies that it needs to be able to do its work. And it has those injected through constructor injection. So we're saying add auto wired, and the constructor has these 3 dependencies, as constructor arguments. And then you'll find 2 different methods, one for reading and one for writing different types of photos. So these different types of photos will, again, they're going to be stored on the MongoDB GridFS file system. We're going to use the Photo Manipulator API, which is a Java image buffer manipulation program that we have written off to the side here in the Spring Doge photo module. This is, as I mentioned, just regular graphics code, nothing particularly fancy. So I won't bore you with that right now. Nothing particularly special. And then finally, we have a repository, the same repository as we created earlier. And that's not bad, but of course, it's very hard to see what a service can do. Much more natural if you can expose it and then let people have an easy way of consuming it, like REST or like HTTP. So the next level is to create a REST API. I like to joke that, while most people, while it has been said that a sophisticated API eventually sends email, I like to joke that eventually a sophisticated API will sprout a REST endpoint. And that's what we're going to do here. We're going to sprout a REST endpoint for our code. So we'll go to our controller package, class, users, REST controller. Paste that in here. Okay, just choosing types here. Very good. So, am I missing anything? So I am. Right, wrong media type. Rhymed. So, voila. I should have a working controller now. Yep. And this controller is just a standard Spring MVC REST controller. You can tell because, well, it's annotated with @REST controller. The REST controller annotation signals to Spring MVC that this endpoint is not your regular @controller, but instead a REST controller whose return values should just be converted to whatever content type is required by the client using standard content negotiation rules, right? So this is in stark contrast to a regular @controller annotated bean whose return values have to have the response body annotation if the payload is to be converted, right? So again, syntax sugar for something you can already very easily do, save for one extra annotation, but it's still very convenient. Other than that, not really a lot to look at here, right? You've got a method for returning all the user data. You've got a method for uploading photos. You've got another method for reading photos, etc. So we could deploy this and just start using curl, but I think we owe ourselves better. Let's actually go ahead and see what we can do to give ourselves something more interactive. We need a web application, right? We're building a web application that in turn talks to a web service. So we'll go ahead and depend on the Spring Doge web module. The nice thing is if you look at our pom.xml, we're just depending on this module, this project. The project itself, it has the usual suspects for a web application, for a client-side web application. It has your normal, let's see, source name, resources, normal JavaScript and so on, CSS assets. I'm using the Bower client-side JavaScript package manager here, so all the JavaScript assets are neatly managed inside this lib folder for me. Thank you. I'm using Angular.js. I've got some CSS style sheets, etc. And then I've got a template selected. So by default, Spring Boot will look inside of source main resources public and expose everything in there at the root of the web application. And by default, it'll look in source main resources templates and expose those templates using whatever view resolver is in there. In this case, we're using the Timeleaf view engine. Timeleaf is a natural templating library. The idea is that you can take a template, make changes to it, and then productionize it. Actually apply expressions and so on to make it more dynamic. and then give that same page back to a designer who can have and continue to retain design fidelity with the original design, right? This is in stark contrast to something like JSP, which let's just be very honest here. JSPs don't really lend themselves to design fidelity for lots of reasons. Scriptlets are one. They insanely picky parser is another, etc. So one solution in the Java community, the Spring community in particular, is something called Timeleaf. It's fairly well liked. It's actually very well liked. As I mentioned, it supports HTML5 natural templates, and it happens to be very easy to use with Spring. So by default, if Spring detects the Timeleaf types on the class path, it'll register that view resolver and that view engine for you. So what we have here are JavaScript files and HTML files that are going to be exposed and made available through the web service here, through the web application. The only thing I think I need to do now is routing, right? So I'm going to go ahead and go back to the application class, register a WebMVC configure adapter, and in that registration, I'm going to add view controllers. I'm going to basically map /client to the view named client, which in this case, of course, corresponds to the Timeleaf view client.html. Same, ditto for monitor and the monitor.html endpoint. This will let us sort of work with a web application page in this module already. We don't have to write all that stuff right now. So I've neglected to define a type of bean here. I forgot to define the photo manipulator bean that's required to drive the service. So let's do that now.
And Josh, we just debug Spring Boot applications with the standard Eclipse debugger?
Yep, you can use a regular. This is just standard Java, so you can use any editor, any IDE, etc. You don't have to use Eclipse. There is a handy-dandy run as or debug as Spring Boot app, but all that does is it finds the entry point class, which is in this case the class with public static void main and the regular applications, and it runs it. So even if you're on some other code page, it'll find the entry point and run it for you.
Cool.
Thanks for that question. Great question. Let's see. Let me register that bean. I'm going to actually register two beans. One to the Java image manipulation library, the Doge photo manipulator. And then another one here is the GridFS template. This is a Spring Data GridFS template. It is it's a template object for working with the MongoDB file system API, the GridFS file system that built on top of MongoDB. And again, we're going to depend on things like the Mongo, the Mongo connection and the Mongo template instance. These are two beans that have been defined elsewhere by Spring Boot. So we don't have to worry about how they get created. We just know that they have been created. They're usefully defaulted, right? So the default Mongo instance is going to go and connect to localhost and connect to a database called test. If I were to define a bean of type Mongo in this application class, then that bean would be given deference, right? So we'd get a pointer to that one instead, as opposed to the default one that gets created in the absence of some other Mongo bean. So not to put too fine a head on it, if I want to define my own Mongo object and connect to some other database, I can. If not, Spring Boot will do it. It's not that Spring Boot gets in the way, it's just that it's trying to help in absence of some particular input from you. Now with that all set up, ready to go. I can go ahead and just run it as a Spring Boot app. By the way, there's a very handy key command, just command 3, and you'll find all sorts of great commands in there, including debug Spring Boot application. See that up here. What have I done now? Let's make sure I have everything here. Doge photo manipulator, GridFS template, set the views, controller. A couple of things I've neglected here. I don't need this messaging template just yet. Got ahead of myself there. I'll remove that. I'll let that out. I'll let that out. Command 3.
Bye.
There we are. That looks more like it. Sorry about that. I had a as yet unsatisfied bean dependency for the messaging template, and I needed that. So our application's up and running. We've got our printed out data, and this is all here. If we go to the browser, localhost client, like that, you'll see that we get our fancy HTML5 interface. And again, if we go to localhost client monitor, we get an empty page. And the idea is that this page, this empty monitor page, should show us the images that we've uploaded on this client on the left. However, it doesn't know when something has happened. Right? This client on the right, this monitor on the right, doesn't know when something's happened on the left. And that implies a different problem. We need some way of notifying the monitor that something has changed. A natural way to do this is to use WebSockets. And it turns out that WebSockets are very easy to do with Spring, and thus with Spring Boot. I'll go ahead and copy this. Again, I've got a cheat sheet here. I'm going to go ahead and register my configuration for WebSocket. Close this down here. Okay. And all I'm doing, I'm using a standard Spring 4 WebSocket configuration. And I'm just doing the part that Spring Boot couldn't possibly get. Namely, I'm naming the endpoints and configuring the particular WebSocket support that I need from Spring, specific to my application. I'm saying I want to add an endpoint named Doge, and I want to enable Sock2JS, of course. Sock2JS is a client-side JavaScript library and a server-side protocol. It's a superset of WebSockets, if you will. So when the Sock2JS JavaScript client connects to a Sock2JS enabled service endpoint, it'll attempt to negotiate a WebSocket connection. Otherwise, it'll gracefully degrade and support, for example, polling or whatever a fallback alternative is. This is very useful for those browsers that don't quite support the latest and greatest stuff. I won't, reasons of modesty, name names and point fingers. But if I were to name names or point fingers, that browser might rhyme with something like Internet Explorer. Again, for reasons of modesty, I won't point fingers or name names. It's beneath me. I won't do that.
I can.
Okay. So with that in play, I've configured my WebSocket support, and on my client side, I'm going to say to my client, listen for all messages, and whenever a message comes in containing a URI that represents the new photo that's been uploaded, go ahead and update the monitor page, right? To support that, I actually need to send that message somewhere. So let's go ahead and reintroduce the bits I commented out from this thing earlier. In this particular case, the bit where we actually send the message, the notification to the client, informing it that that an image has been uploaded. So voila. Okay, so now I have my REST controller, and on file upload, when an image is uploaded, I send a notification to topic/alarm, and I send as my payload an object, in this case a map, that will be converted to JSON, and will have as its fields the keys in this map, right? That's just a natural mapping from JSON to a map. And then since we've only got one key and thus one field, we can use the singleton map convenience method in the collections class that comes with the JDK. And so you're going to get a JSON structure with this little Doge photo URI, and then we're going to let the client see that change and update its state. Let's rerun the application. Okay. Reload, refresh. And now we can try it out. We can see what we've got here. Go here. Go here. We'll start with something. You know, we want to stress test this thing as best as we can. So we'll bring to bear the full and awesome power of David Hasselhoff. Drag that image onto the app on the left, and oops, I forgot to configure multi-part config. So this is the one last piece I need. There you are. I need to tell Spring Boot where I want to say, you know, how much data I want to enable to be uploaded. So remember, by default, Spring Boot uses a Servlet 3 environment, and in that API, you have the ability to use the part API, the Servlet part API, to handle file uploads in lieu of something like, for example, Commons file upload. Here we're going to go ahead and just restart the application. And so what we're saying is when files are uploaded, we want to have a file no larger than 10 megs, otherwise reject it. You can also configure where it's
Josh, looks like we lost you on the audio there.
version of the Hoff on the right. That's awesome.
Yeah, we lost you on the audio there for a second. You might want to back up about 1 or 2 sentences.
Awkward. Did you guys at least see the really, really awesome part where we brought to bear the full awesome power of the Hoff? Okay.
Yes, we only missed 1 or 2 sentences. No worries.
Then you have self-actualized. It's okay. As long as you saw that. So you know, we can also bring Mr. Doge himself, right? So drag and drop over there, and you get the Dogeified version of Doge himself. Look at that. Even the captions are awesome. That's boot. That's awesome. So okay, we've got a basic working web application that supports. It's a web application babysitting a database that we've assembled here from you know, very few pieces very quickly. We didn't have to configure Spring Data. We didn't have to configure Spring MVC. We didn't have to configure well, almost anything really. We had to configure things that Spring Boot couldn't possibly know about. For example, the names of our endpoints or our sample data, like the seed data here, or the WebSocket endpoints for applications. Otherwise, we got away with not having to configure much at all. You know, so this is really the value of Spring Boot. But if this was all Spring Boot represented, then well, you know, just being honest, it wouldn't be as cool as my excitement should lead you to believe. It's actually quite a bit more, right? So what does it mean to get what does it mean to get an application into production, right? To quote the Epic Tome release it, feature complete does not equal production ready, right? There's quite a bit that has to be done to get something out, get something production ready. And a lot of that is management, it's monitoring, it's insight, it's metrics, it's analysis, it's all this stuff. And Spring Boot has all that stuff in spades. So we're going to go ahead and take a look at some of that stuff right now. Designed to promote visibility and transparency, and to support, monitoring, these kinds of things that teams spend a long time getting right. That should just be out of the box now with Spring Boot. So okay, let's look at common things. Let's suppose I want to see, how my application is doing. Let's suppose I want to see the health of the application. I can go to the health endpoint, which we didn't have to configure. It's just there if you have the Spring Boot starter actuator module on the class path. By default, you'll get a default string here. If you're using a SQL JPA stack, you'll get the last known exception, if there is one, and you also get the name of the provider. For example, for using H2 as the database, you'll see that reflected in the structure that's shown there as well. There's another endpoint called metrics. Metrics shows you all the requests that have been made and their status code. So, for example, there's a call to the client endpoint / client one time. It has a status code of 200. A call to the health endpoint one time, status code of 200. If I go back to the client here, let's go to localhost client, refresh, and then go back here and refresh. You can see it reflects how many times we've done it, 9 times, right? This is fine, of course, but sometimes some people don't want that directly on a website. They prefer to get at it from a more traditional management tool, like for example JMX, a mechanism like JMX. Well, turns out Spring Boot automatically exports the stuff via JMX as well. So you just launch your JMX console, in this case JConsole, and sign in. MBeans, Spring Framework, Doge, and you can look at a lot of the same stuff that we saw before. There's the metrics endpoint, call get data, and you can get this the same kind of data we saw before, just inside of JMX. And if you have ever played with Spring's very, very rich JMX support, that there's good support for example, reacting to a change in a property or querying data in JMX and so on. So if you want to build something that reacts to this data, you can very easily. But there's more, not only does it slice and dice, but there's even more. So another very, very convenient way to get access to this kind of information is to use the CrashHub shell, which is, again, very easily supported if you have the right types in the class path. Spring Boot automatically configures it, and by default, it'll configure a username and password, and it'll print out the password on the shell. I've pinned the password down to a specific word, meetup. I did that by specifying a property in this property file. By default, Spring Boot will look for properties in a file called application.properties or application.yaml, assuming you have a Snake YAML library on the class path. In this case, we're setting the password to be meetup. So we're saying username is user for the shell, and then meetup is the password. By the way, I should mention that if you want to know what other properties can be used to configure your application, there is a very handy endpoint called config props, which shows you for all the beans that are active right now, what properties you might stipulate or specify to override things, for example. So if I wanted to override the server port, the port on which the embedded Tomcat that we're using to serve the web application missing, I might specify server.port in the property file, and then specify 8081 or some other port, and in that case, that will be honored, right? So this is a very convenient way to override the default behavior without having to reprogram everything yourself. Again, another example of Boot deferring to you, but providing a useful, sensible default otherwise. So now, with that said, we've established that we have a shell running. It's listening on port 2000. Username is user, and running on localhost. The password is meetup. Hit enter, and we're dumped into this crashd shell. There are a few commands. The slowest of which is help. If you issue help, it'll just take forever the very first time, but of course, subsequent runs are very quick. Lots of good stuff in here. You can, for example, the endpoint list will, show you all the endpoints, and you can invoke one of them. So, for example, invoke that, voila, etc. You can use JVM type for JVM system to get information about the system, for example, runtime. You can do system prop ls to see all the environment variables, the system that give properties, and I've enumerated all that. Tab completion is very nice here. It works very nicely. Metrics, again, we saw that earlier, but it's again available in the shell, the enumeration of which requests were made and so on. By the way, you'll notice that we're using here counters and gauges. This is a subsystem that Spring Boot provides that you can contribute to as well. You can emit your own data if you want. And indeed, you can control how that data is published, and we'll look at that in a second. One of my favorite endpoints is, of course, dashboard. It shows you Java top, if you want, the top, and then memory on the bottom right here, for example, as well as the environment on the left. On the right, you'll notice that we're using Metaspace. This is a Java 8 feature. It's the successor to the much hated PermGen space that we had before. And so Metaspace is the Java 8 equivalent, but if you had a Java 7 DSA, then this would show you PermGen instead. Again, very, very convenient. All this is secure. You can defer it if you like to a Spring Security stack if you wanted to otherwise. But again, by default, we're just using the password and the username that we've specified. Okay, so that's not bad. We got a lot there. I mentioned earlier that you can override the metrics and override other things like that. Let's suppose, for example, that you wanted to override how metrics are published. And let's also suppose that you wanted to override what it meant for an application to be healthy. Well, I want to change the application's definition of health. I want to use my own definition because I have a better idea of what it means when my application is healthy or not, right? So I'm going to go ahead and contribute a health indicator type. And again, I'm using a Lambda expression to satisfy the functional interface that is health indicator. I'm saying, try and connect to Mongo. If everything works, return the string OK. Otherwise, return a failure. And of course, you could easily tie this to something like New Relic or Nagios or whatever your monitoring tool du jour is, and that'll work. And then also, I want to configure metrics. I want to configure how the metrics are published so I can visualize them. In this case, I want to visualize them using something like Graphite. The metric system that Spring Boot provides is rich and it's powerful and very expressive, but again, we're not trying to reinvent the wheel. Wherever possible, we provide integrations with existing technology. One very, very popular tool chest for metrics is something by a gentleman named Coda Hale, the Coda Hale metrics library. It's a library from Yammer, if memory serves. So what we're going to do here is we're going to register a custom configuration class. I'm going to publish or register a Graphite Reporter bean, and this is going to publish what's happening in our application to Graphite, which is a graphing and analysis tool, right? Fair warning, it's not for the faint of heart if you have not set it up before. I don't know, bring some whiskey or something. It'll take a little while. Now, with that up and
lost you on audio again for a sec there, buddy.
I'll show you that in a minute, but we needed to be up for a minute.
Josh,
yes.
back up 2 sentences. The audio cut out again. Sorry.
Oh, sure. Now we have a custom health endpoint, right? This is our custom health endpoint that defers to the health indicator that we've just installed. Again, if I were to kill MongoDB, this would reflect that immediately, which is good for monitoring, right? You want your pager to go off as soon as possible. I'll do that in a minute, but before we do that, let's create some traffic and some impressions so we can go to Graphite and see it in action, right? So again, Graphite is installed on the system. It's not easy to install, but we got it done. On my computer, it's running on port 9090. And you can see it is already being published to it from our Spring Doge application. And you can see all the sort of usual suspects that we saw earlier reflected here, right? So I'm going to go ahead and zoom in, or I can see the data here. This is the default Graphite install. There's actually a very convenient Graphite client, which is far more reactive, if you will, called Giraffe. It's an HTML5 based client. So you just take the HTML5 page, drag it into a browser, and there you go. You can actually see some of the data being stair-stepped in. This is all data. This represents what we've been publishing from the web application itself, right? So you can configure how this data looks and what it does, but suffice it to say, this is very, very convenient stuff. This is very useful stuff. It helps you react and plan accordingly. You can see what happens when your application dips into too much load and so on. Okay, so last trick. Let's go ahead and kill MongoDB. Fare thee well, Mongo, we knew you well. Okay, go back to the application, refresh, and of course we get error, right? So our customer health indicator tells, it works. It knows how to warn that our system is down. So if we log into CASD and ask for the health there, or look at the JMX as well, all of those endpoints would not reflect that there's an error, something is wrong. Again, we could have returned a full-on JSON object, but we just returned a little string token. Okay. So I alluded to it earlier, but there's a couple of different deployment options you can use. By default, we're using an embedded Apache Tomcat 7. You can use embedded Jetty if you like, Jetty 8 or 9. You simply exclude the Tomcat starter and then install the Jetty starter, and voila, Spring Boot will defer to that instead. If you'd like to package up your application for deployment to a traditional application server, a standalone, traditional Tomcat, or even a Java EE application server, what have you, there's absolutely no reason you couldn't. It's just fine. By default, you have a fat jar with Spring Boot. This is an ideal choice for cloud environments like a platform as a service, where they favor the bring your own container model. All this time, we've been relying on the default that Spring Boot provides. We've been looking at, we didn't have to configure any of the Spring Data stuff, for example. We didn't have to configure Spring MVC. We didn't have to configure a lot of that infrastructure. That's possible through the magic of Java configuration, or of auto configuration. So when the application starts up, we see the @enable auto configuration annotation. That tells Spring Boot to scan the class path and to find all spring.factories files in all of the jars that have them, and then to activate the class enumerated by that property. So I can show you one here. Spring Boot order actuator. Here we are. And Spring oops, wrong one. That doesn't have it. Spring Boot starter auto. Spring Boot auto config. Very good. Good. So meta-inf spring.factories. And you can see here we've got org spring framework boot auto configure enable auto configuration equals, and then a comma separated list of fully qualified class names, Java configuration class names. And you might be wondering, that doesn't sound good, right? I don't want all these different classes to be activated when my application starts up. And thankfully they're not, right? So these configuration classes build on a Spring 4 feature called @conditional, which lets you conditionally activate a bean or configuration class. Think of it as a much more broad spectrum, much more general purpose facility like the profile facility. In fact, the profiles mechanism has been retroactively made a specialization of the conditional mechanism that's been introduced in Spring 4. So we can use @conditional to say, based on some condition, and it can be arbitrary, right? You can define your own. So based on some condition, activate the bean or bean tagged with that condition. In this case, you can even say, don't activate this class if the Rabbit template and channel type are not in the class path, right? In this case, these are not in the class path. I can't click on this. So this class will never get activated, which is good, right? I don't want RabbitMQ infrastructure to be created and loaded if I have RabbitMQ on the class path and I have no use for it in my application. So again, we're doing as much as we can based on what's happening, based on cues in the environment. Okay. couple of things before we go. There are already many other projects using Spring Boot, Spring XT, the turnkey big data appliance we looked at a little bit while ago. That's been rebased to sit on top of Boot. JHipster is a Yalman, which is a Node.js ecosystem code generation, Swiss Army knife tool type thing. And there's a technology called JHipster, which builds on that code generation thing and generates Spring Boot applications. The Vaadin component framework has a nice working boot integration, and in my humble opinion, it's actually a nicer way to use Vaadin than Vaadin by itself. Activity too has one. Numerous people, if you read Speak in Spring, for example, this roundup I put together every Tuesday, there's usually just lots of posts about people who are using Boot and who have, in some cases, moved their entire application workload to Boot, and the result has been a net reduction in code. I mentioned all this, and I should mention also that Boot just went 1.0 GA a couple of weeks ago. So all these things I've just mentioned are people who are very, very earnest and very, very, very impressed with it. They've embraced it early on, and it's been stable, and they're using it. People in the community like Matt Rabel are blogging about it, so lots of people are very excited about this technology. Right? A common question we get is, what about live reloading of classes in templates like in Grails? In Grails, that feature is enabled through something called Spring Loaded. We support the same thing. If you check the documentation, you can use Spring Loaded with Boot. I mentioned earlier that you can use, by default, Spring Boot will check for properties in a property file called application.properties or applications.yaml. Of course, you can register a custom property file using the app property source mechanism or whatever. There is a particularly nice Groovy integration for Spring Boot. There's a command line tool that you can get if you do brew install Spring Boot on the Mac, for example. It's a tool that spares you even the boilerplate public site void main, the 4-line public site void main application entry point that we had to write earlier. Even that can go away now, right, with the Spring command line tool for Groovy code. There's also an event subsystem. It builds on top of the application context event mechanism that's available and that's been available in Spring since day one. And basically, Boot uses it to publish sort of life cycle events that you might want to be aware of, more higher level ones. Like, for example, if somebody authenticates with a Spring security principle, you can get a notification. You can get an event published, and that's stuff that is specific and unique to Boot. I want to draw your attention to these two Twitter handles, Dave Sire and Philip Webb. These are the co-leads, the people that started Spring Boot. I think they're rock stars, super people, amazing, real mentions. And I just wanted to say thanks very much for an amazing technology. Thanks for supporting me in this talk as well. So, and I worked on the code, for example. I am and remain Starbucksman at Starbucksman on Twitter, and I am, as always, your humble servant. So don't hesitate to reach out and carry the discussion there. If you want the code, it's on GitHub, and of course, don't hesitate to check out the docs and everything else. And with that, I'll turn it back to you guys for questions.
So Bassem Zodi has been very patient. He asked a question a while back. Right around 20 or 30 minutes ago, he was curious where the part of the code that is actually calling the REST service was.
That's in that JavaScript code that we looked at in the web module. So we enabled an HTML5 drag and drop thing, and we had another bit that actually gets a notification from WebSockets. All that JavaScript code. Do you want to actually see it here? Spring Doge Web, as I mentioned earlier, we split out the client-side artifacts, the HTML5 templates, the JavaScript, and all that. We split it out in one module, and the server-side enterprise Java bits are in a different one. And we just, thanks to Spring Boot and Spring MVC, we've exposed all the assets that are in the website through the application, in the REST API. So these JavaScript assets, that's where all that stuff is. All the REST calls, all that stuff is in this JavaScript code somewhere.
Got it. And you said you were using WebSocket for that, so that when you drag the photo it would immediately kind of, ping the reload or
Exactly.
ping and trigger a reload.
Trigger the reload, exactly. That's WebSocket support.
That's a cool technique. Nice.
And that is an important point, by the way. Everything we're doing here, you can already do with Spring. Well, actually, a lot of the management and monitoring bits, but everything we're doing here is building on top of technologies that are already available. But again, the goal is to really, really make it simple. So it should just be very easy to pull in WebSockets and to pull in REST and to pull in data and all that stuff.
Yep. Great. And then Bassam, please forgive me if I'm pronouncing your name incorrectly, had one more question. He was curious how to access embedded databases like H2, for example. I think you were using Mongo on this one, but
yep.
It should be trivial to work with an in-memory database, I think.
Yeah, so by default, if you have H2 on the class path, if you have H2 on the class path and absent any other explicitly configured Java SQL data source, Spring Boot will create an embedded H2 database for you. Same thing for Derby or for HSQL. If you have the requisite libraries on the class path and you don't explicitly configure a data source beans, it'll create one for you because it senses that you want one. And why would you have the library on the class path if you didn't?
Just by putting it on the class path, Boot configures it for you automatically. Wow. Okay.
Indeed. It's really trying to help. But again, it'll back off if you configure one yourself. So and you can use the Spring profile method. You can say I have one configuration for dev and QA, for testing and production and whatever, cloud, whatever.
And you once told me that if you put a .SQL file in the right place, that it'll actually make the database for you. Am I remembering that correctly?
Absolutely. So if you put a schema.SQL in the source main reasons folder, it'll load the DDL from that. If you put a data.SQL in the source main reasons folder, it'll load the SQL statements to the C data. So earlier on, since we're using Mongo, I used the repository to programmatically insert free records into the database. But if I was using a SQL database, I could just put that in a SQL file and it would get run at startup.
Wow. So no more. Wow, that's pretty cool. Okay, so we know a lot of people use MySQL. So if that's the use case, you just drop your development schema in the SQL file and you're done. That's pretty cool.
I'm a big fan.
All right. Sam, thanks. I hope that answers your questions. I think we're pretty much done. We're a little over time, folks. So thank you so much for joining. And just want to let you know. Yeah, absolutely. Just want to let you know we do have some other cool webinars coming up this month. If you are around on the 30th of this month, you can come back and join Josh again. He's going to be joined by Ashley Poles from New Relic, and they are going to talk about how to do web app diagnostics when you're working with web applications where you have like a Spring backend and a JavaScript frontend, which is very common these days. And it's an architecture we've been espousing and talking about it at Pivotal and with the Spring team for 2+ years now at least.
Forever and a day.
Yeah, no kidding. So that'll be on April 30th. So please join us for that. In fact, I'm just going to see if I can pop the URL for that here into the question and control panel. Let's see. Oh, and Bassem had one other question. So let me. Oh, cool. Actually, we're getting a few more questions come in now.
Cool.
So Roman Ivanenko asks, if I use schema.SQL, how can I detect if the schema already exists?
So this is actually a Spring JDBC mechanism, and it's using the data source initializer types, and it can be programmed to fail on error. But by default, if you have an error, like for example, if you try and execute a DDL statement that fails because that table already exists, it'll just skip it, right? So you can usually just go ahead and blindly try and execute something, and if it already exists, just ignore it. But if you want to detect if a table already exists, that's up to your particular vendor's DDL supported syntax. There's no standard way, right? Like for example, in MySQL, you can say if table exists, for example.
Awesome. Thanks, Josh. Yeah, I mean, most of the time I would see people write their SQL statements to like drop the tables first and then create them, but that's assuming that you're in a development mode and don't have data in there that you care about, right? So that's just another thought for you, Roman. Bassem also asked, he faced one problem when used Spring Boot Data JPA with Data Mongo in the same project. Are you supposed to use them together?
I don't see why not. Yeah. I don't know what the specific problem is, but you might have some issues with repositories themselves. But for example, if you just wanted to use Spring Data JPA and you wanted to have an entity manager and you wanted to work with the Mongo template, there should be, for example, no problem there. But there are solutions for doing two different types of repositories in the same Spring app.
Yep. Okay. Well, just a quick recap. So I think we just had a couple questions in. I always like to give priority to those. So just a quick recap. We are going to be join Josh on the April 30th for New Relic and talking about debugging JavaScript apps front to back along with the Spring backend. And then on April 22nd, Mike Milinkovich from the Eclipse Foundation and Martin Lippert, our lead on Spring Tool Suite, is going to be talking about a new and exciting project at the Eclipse Foundation called Project Flux. The idea of that is to begin to bridge the browser-based editing experience and browser-based IDE experience with the Eclipse IDE. So that should be pretty interesting. Something that Mike Milinkovich, who is the executive director of the Eclipse Foundation, they made a big splash at EclipseCon. And something he's particularly interested in. So very cool project. You might want to check that out. And we will post the replay of this talk in the next 2 weeks. Often we get to it a lot faster than that. We'll post that at spring.io/video. And it seems like a few people had issues with sound on this webinar, so just apologize for that. Not really quite sure what's happening. We'll do our best to figure it out.
It did skip on my side a few times, right?
Yeah, just a couple, but no one's giving me specific feedback on what they're specifically experiencing. But yes, we will. We try to take great care to make sure that the audio is good, and we'll be posting a replay of this within 2 weeks, often a lot less than that. So with that, thank you very much. Appreciate everyone's time, and hope to see you on a future webinar.
Thank you.
Take care, everybody.
Cheers.
Bye.